See, this is a thermostat that was replaced from a water heater. Okay, and there's actually nothing wrong with it. It only needed a thermal cutout reset, or they call it a safety reset, which is actually marked there, and I'll show it in the video. Look at the safety reset. This you are seeing in a zoomed in view. And so in an on condition, okay, this is a neutral line, it's on. You can see that there the live side is also on. These two terminals are for the indicator, and this is actually connected to this one, which actually connects to the element, heating element. This is the rod that inserts inside the element's jacket. There's a jacket inside into which this one is inserted, and it doesn't make contact with the water, but effectively it senses the temperature by virtue of that being a brass or a copper or something like that, or maybe stainless steel as well, perhaps some models, and it will sense the temperature plus or minus a couple of degrees, doesn't matter. So apart from being a regular thermostat, and the thermostat meaning you set the temperature and which it reaches the temperature, it cuts out, and then it resets when the temperature falls below that level. That's one function of this one. Although it's known as a thermostat, it also has the additional function. Assuming the temperature is reached. Now I have to simulate that condition. I hope that sound was heard. There was a click. That's exactly what happens even when the temperature rises and it reaches. What I did essentially was reduce it to ambient temperature and below, and now this one cuts out, is open, but the neutral is still on. So when you look at the schematic, you will understand the thermostat is only on one line, only on the live line, whereas the thermal cutout cuts out both the units, both the lines. When the thermal cutout cuts out, it doesn't reset by itself, and that's exactly what happened. And here we have a manufacturer's service guys come there without even looking at whether the reset has been triggered, just decides to change the thermostat. Okay, we'll leave it at this. My comments will be commented later, and that was not the right thing to do. So now I will show you what is the other part of it. Okay, so let everything temperature back, and then it contacts back again. I set the thermostat back into where it should be on. So, and these are 2 points where the indicator goes from, and you can use the same point to measure, where you can either measure like this or whether I can measure like that to this terminal with respect to this terminal. It's the same thing, Let me show that in any case, and I'll just record this. It's the same. So it's a lot convenient to measure it and show it from here. But in actual position, you can test it with the voltage when it's all wired in powered condition and a non-powered condition. In a non-powered condition, if you isolate both the lines, you can measure resistance just like this. Alright, so let me open up and show you the thermal cutout part of it. The thermal cutout part, now this is something that I came back, they were done with the rivets, so I drilled out the rivets, I opened it, I wanted to see everything. I wanted to see whether the contacts worn out, nothing wrong. And then looked at it and then saw that the thermal snap disc, the thermal cutout, which is underneath here. Right now it looks pretty more like a concave, or more or less flat. This is how it sits. But should the temperature goes, when you flip over and you can see some marking, and from the marking I guess this is set for something above the 75 degrees. So maybe around when temperature hits about 80 degrees plus another 5 degrees, 85 degrees or something, when it reaches here, it will just snap. This is not what you call a snap disc. It is actually a bimetallic. It's made out of two metals, and the outer part of it is made, then it's coated, so you don't even know the difference. And it has a structural way of doing it. So you see, I can demonstrate this, what happens when heat gets into the thing. From a flat, see, it just became a convex. When it goes into that mode, it cools up quite fast. When it goes into that mode, I'll put this back in that mode and then show you what happens. When of course, this is where this is a knob that is adjusted by this knob. It engages to this yellow socket, and which is eventually adjusted by this one to set the thermostat. The normal temperature sensing on and off kind of thermostat. All right. Now, when this is a thermal safety cutout. So this one, when this become a convex pushing out, what actually happens is that right through the center, it pushes on this knob, this rod, this tiny rod, and it disengages, and then it pushes against this rod. You can't quite see it because that happens in between. It pushes both the contacts away, and if you look carefully, you would see that the safety reset has pushed out. And in this mode, both the terminals would have disengaged, out and out. And this is all that was needed to be done. The safety reset is just done by this point. You hear this carefully. And then it makes contact. That was all there is to it. Now and this is perfectly fine. Now what that is all done, and of course you don't even need, now that I've opened it, I've cleaned the contacts and all that anyway, but that was not even required. There was nothing much wrong with it otherwise. Somehow the temperature would have gone beyond, it would have been set too high, gone too high, or an electrical surge or something would have tripped it. And that's how the safety reset got triggered. That's all that was needed to be done. You didn't even have to change this. There's nothing wrong with this. I will finally build this back, rivet it back, and it's ready to be reused. And instead, a thermostat was replaced for no good reason and built for such services, including the cost of that thermostat, which was uncalled for. As a consumer, did not know there was a safety reset, and nowhere in the manual is it said that there's a safety reset that needs to be. So that is something wrong on the fact of the manufacturer, particularly wrong on this part of the service guy, who should have known this. Only saw the safety reset and how it was done. Now what has happened, only when I looked at it when they had the thermostat in my hand. By then it's already been changed and it's been too late. But I still had to bring it to your attention. At the very least, many more people will probably understand from this, will probably learn from this.